Alright, so let's see apple division. We need to divide the apples into two groups so that the difference between the weights of the groups is minimal. So we will be given with the apples and we need to divide those apples into two groups. We need to segregate them into two groups so that the difference of those groups is minimum. As an example, we have 5 apples and these are its corresponding weight 3, 2, 7, 4, 1. Let's visualize them. This is the weight 3, this has weight 2, so it is a little smaller. This is weight 7 bigger, weight 4, and weight 1 even more smaller. These are its corresponding weights. Now we need to divide them into two groups. So two groups, that means we have two crates, two boxes, and we are going to fill them with these apples into these boxes. So if I put the first, second and the fourth apple in the blue crate, so the total weight will be 9. 3 plus 2 is 5 and 5 plus 4 is 9. 3 plus 2 and this 4. Now this third and the last one, 7 and 1, will put this in orange crate. So let's put this is 8. So we have successfully divided them into two groups, and if you see 9 minus 8 is 1. So this is the max possible minimum weight. If you do any other arrangement, that would be give this less than minimum 1. So alright, so this was an explanation of the problem. Now let's look at the more examples. Here we have 3 apples, 5, 7, 9, and this truth table tells each time gives the all possibilities of selecting the apples. Meaning here we have two crates, blue and orange. Blue means 0. So if these are 0, that means we are putting all the apples in this crate, and 1, that means that available apple we are putting in this orange one. So as in first example, we have 0, 0, 0. That means we will put all the apples in the blue one and we will have this way. So 21 minus 0, because we are not putting anything in this, there is no 1. So there will be 21. Now in the second one, 0, 0, that means we are putting 5 and 7 to this one. So 5 plus 7 is 12, and this one 9, that means we are putting in this crate. So the minimum is 3. So till now the minimum is 3. Now in the next one, we will put 5 and 9 in this one. So 5 plus 9 put in this one, weight will be 14, and the 7 will be in the orange one because it is 1. So the minimum weight will be, the difference will be 7, but it is not minimum. So like this we will keep on doing this. You see, this tells all the possibilities. First you are keeping all this here, then you are putting the other one here, and in this last one you are putting everything here. So this is giving all possibilities. No solution is missed out. So that means we are applying here again brute force, because this brute force gives all the possibilities of the solution available to the problem. And to construct this table, we need 2 to the power n, that means here 3, so 2 to the power 3, that means 8. So you will be having 8 possibilities to fill in this crate, and accordingly you will find the minimum solution. So let us look first this. So this will be having 2 to the power n execution time, and constraint given is n would be less than 20. That means 2 to the power n, 2 to the power 20 is this one, and this value is surely less than 10 to the power 8, because in 1 second we can handle up to 10 to the power 8 execution, and time limit is 1 second. So this value is less than 10 to the power 8, so we can apply here brute force. Alright, so let us build us the logic using the brute force, and we will use recursion to fulfill this brute force approach, because first of all there is many branches meaning there is, first you are selecting 0 0 0 means you are going to this 0 0 0, then you are taking 5 and 7, then not taking the 9 you are putting there. So there are many branches being made. And the second one, the formulation of single idea can be repeated multiple times. First selecting this one and not selecting that, then selecting this, that. So there is a single idea of selection. We'll see. So we will have two crates, this blue one, the orange one, and this line is what explain our idea. And then we will either add apples to first or second and keep holding the minimum weight. Let us break this one by one. We will either add in crate blue, so the apples will be either added in crate blue. Index means that 3, 7, 9 and indexes are I, 0, 1, 2. So if we are here, so we will add either in crate blue. So here we are adding in crate blue. Again, we will either add apples to first. So I have made the apples to go in crate blue either, or we can put in the second one. So here I am putting in the second one. So either in crate blue or crate orange. Then when you are adding in crate blue, crate orange will remain like this. And when you are adding crate orange, crate blue will remain like this. Then you need to also increase the indexes. 3, 7, 9, you will go here, then you will go here. You are going to increase the indexes. Then you will call this minimal function again, right? You will call again with these increased indexes values, but you need to what? Keep holding the minimum weight. That means you will be having a min function to get the minimum from these two. If you are adding in blue or an orange and get the minimum of these two. So that's what this is going to do. And let us code this also, where we will have a better understanding. This is just a rough idea. You may be getting all confused. So let us code this. After coding, maybe we will do some try and run to perform and check how this recursion is working. Okay, so the first line contains integer n, the number of apples. Then the next line contains the weight of each apple. Let's write int n is this, because n is less than 20. And then we need to also get the weights. So we'll say I is 0, I is less than n, and I plus plus, and let's fill this weight. It is less than 10 to the power 9, so better to use what we have defined, macro ln, and these are weights. So we'll get the weight and then we'll push this into apple. So apples is not defined. We'll create a vector for it. Let's create a vector here of ll only and apples, and we'll push back this weight. Now we'll create a function minimal, and what we need to pass, let's check here, indexes crate blue and crate orange. So for the time being, let us make everything 0, and we'll write here minimal. and what it is going to give, it is going to give minimum value. So let's define the data type as int, and first is contains the index, then create blue, and create orange. These are our creates, and what does this specify? This specifies the weight. Create blue weight and create orange weight. Now we need to get what we need to do. We need to call this function, which we wrote here. So let's try this. Return minimum of what we need to, or we write from backwards. We either add in create blue, the apple, and wait a second. This apples is not defined here because it is a local variable. So let's copy this, cut this, and make it a global. So this apples will be present everywhere. So we are adding in create blue, but also we can add in create orange. So let's write create orange, the apples. And when we are doing this, create orange will remain as it is. And when we are doing this one, adding in create orange, summing up the weight, summing this create orange, create blue will be as it is. Now, since when we are adding in create blue, create orange is as it is, and when we are in adding create orange, create blue is as it is, then index has to be increased. Let's wrap this in minimal. This is our minimal. And here also index has to be increased. So we'll increase the index, and first we need to write pass the create blue, then we need to pass create orange. So let me just cut this here. Alright, and we need to give the minimum. We need to return the minimum of these values. So we'll write min. Alright, so this is our function. So we are either adding in create blue or in create orange, and when we are adding create orange remains as it is, and or either create blue is added and index is been increased, and we are calling it again. And now let's check the base condition. What can be the base condition? So if 3, 3, 7, 9, these were weights, apple weight. So we are either summing up in create blue. Create blue is nothing but weight of the create blue. So indexes, we need to scan through all the weights. So we will stop when index reaches the end position. So what is the end position? The number of weights, 3. So when the index reaches here, we need to stop. So we'll write if index becomes equal to n, then we will return the absolute value of the difference. The absolute value of the difference will be written here here, the calling function, and also if when we are calling this will be returned here, and the minimum of these two will be taken in consideration. Alright, so let's write if index becomes n and index is 0, 0, 1, 2. These are indexes, and 3, 7, 9, n is 3. So we'll here check here, then we'll here check here, then we'll here check here, and as index increases, index plus 1, index will be here. So that will be 3, 0, 1, 2 and 3. So we are now going to check with n equal to 3. Alright, so if index is n, then what we need to do? We need to return ABS create blue minus create orange. We need to do, and if it is not, then we need to do the else part, this. And we should make this long 0, because to be under the limits, and when we are calling this is going to give the minimum value. So let's call it, let's say LLM, and we'll display the okay. So everything looks alright. Index is equal n is undefined because I have made it local. Let's cut this and paste it here, so it becomes available everywhere. Now index create blue, we are going to this, and alright, so let's submit this. Token is missing in 13. Okay, so I have not put a semicolon here. Submit it again. Okay, so it's accepted. Alright. Okay, so let us trace this function for n equal to 3 apples, and these are apples 5, 7, 9, and these are indexes 0, 1, 2. So let us trace this and make it more understandable. This function is going to be called with these values 0, 0, 0. So index is not equal to n, index is 0 and n is 3. So it will go here else part, and it is going to run this. Let's run this. We'll say minimal index plus 1, that will be 1, index is 0, and create blue is 0, 0 plus apple of index 0, index is 0, so apple 0 is 5, so 0 plus 5, and create orange is 0. And let's write this function also. First we are going to complete this and we'll come back to this, but let's write this also. So this will be minimal, and index plus 1 will be 1, and create blue is 0, and create orange is 0 plus apple of 0, that is apple of 0 is 5. Let's run this one. So index, now we are here, index is 1 and n is 3, it is not equal, so it is going to in else part, and we'll write minimal. Index plus 1 will be 2, this will be 5, and index is since 1, so index apples at index 1 is 7, so 5 plus 7, and this will be 0. And let's write this, but we'll finish off this, then we'll execute this. So let's write minimal. Index plus 1 will be 2, create blue is 5, and create orange is 0 plus apples at index what? Index at 1. So this is 7. Alright, so this is done. Now we'll finish this call. So I will say, since index is not equal to 3, it is going to else part and it will start minimal. Index plus 1 will be 3 since index is 2, and create blues plus apple at index 2. So 5 plus 7 plus index at 2 is 9, right? Index at apples at 2, that is 9. So 5 plus 7 plus 9, and this will be 0. And we'll write this one also. Minimal. Index plus 1 3. Create blue is 5 plus 7. And create orange is 0 plus apple at index 2. Apple at index 2, that is 9. So now it will go again. Now you see index is 3 and n is also 3. So index is equal to n. So it will not go to else part. It is going to return the absolute value of create blue minus create orange. So here this is create blue, create orange. So there this will be 21. This will be 21 and this will be 0. So 21 minus 0, this will be 21. So this is going to return 21. Now it will go again and it will execute this one, since this is left at that call. So this will be 5 plus 7, that will be 12, and 12 minus 9. Since here also index is 3, so we are performing this step since index is 3. So 12 minus 9 would be 3, and you see we need to return the minimum of this. So minimum of these two quantities is 3. So it will go back to the calling. So this will give us 3. Now this is written. Now we will execute this one. So let us execute it here. If there is no space, I will execute it here. Now again this call has to make minimal. Index plus 1, that will be 3, and this will be 5 plus apple at index is 2. So 5 plus 9, and this will be 7 as it is. And we'll write the other half, this one also. We'll say minimal. So index plus 1, that will be 3. Create blue is 5 as it is, and create orange plus apple at index 2. So create orange is 0 plus 7 and index 2 is 9. So this one. Now since index is equal to 3, it is going to now execute the if part. So absolute create blue minus create orange. So create blue is 5 plus 9, that will be 14. 14 minus 7. 14 minus 7, this will be 7. Now here also index is equal to 3 and it is going to execute the difference. So absolute difference. So 5 minus 7 plus 9 is 16. So 16 minus 5 will be 11. So this will go back to the calling, and here it will give 7. Minimum of these two, that will be 7. Now it will go back, and minimum of these two will be 3. So it will go back here and this will be 3. Now we need to execute this part. This is also left. So let us execute this also. Separately we'll write because there is no space. So index is 1, create blue is 0, and create oranges are 0 plus 5. Remember this. So we'll execute this here down. Okay. So yeah. So 1 0 5. Minimal 1 0 and 5. Alright. So let's start executing. min index plus 1. So index plus 1 will be minimum 1 plus 1, that will be 2. This will be 0 and 0 plus apple at index is 1. So index at 1 is 7. So it will be 0 plus 7 and this will be 5. Write here this one also. Minimal index plus 1 2 and create blue will be as it is 0 and create orange apple at index 1. Index 1. So this will be 0 and this will be 5 plus index at 1, that is index is 1, so 5 plus 7. Yeah. Now we'll execute this one. So this will be minimal index plus 1 will be 3 and this will be 7 and index 2, right? Index is 2. So create blue plus index at apple at index 2, that will be 9. So 7 plus 9 and this will be as it is. We'll write the other half also. Minimal index plus 1 will be 3. This will be as it is, and 5 plus index apple at index 2, that will be 9, right? Apple at index 2 was 9. So this will be. Now since index is equal to 3, we are going to return back the absolute difference of create blue minus create orange. So 7 plus 9 would be 16. 16 minus 5 would be 11. And this is also the same. Index is equal to 3. So this will be 5 plus 9 would be 14. And 14 minus this will be 7. Now this is going to give the minimum. So minimum would be 7. This will come here. Now we'll execute this part. This is left. So let us execute that also. So minimal index plus 1 would be 3. This will be 0 plus index at 2, and we have apple at 2 is let me see 9. Apple at 2 is 9, and this will be 5 plus 7. Let's write the other part. Minimal index plus 3 3 and we are executing this, and create blue is 0 and create orange plus apple at index. So this will be 0 and this will be 5 plus 7. Right here 5 plus 7 and plus apples at index 2. So apple at index 2 is 9. So let us write 9 here. Alright. Since this is now 3, index is 3, so we'll give the difference of create blue minus create orange. So this will be 12 minus 9. This will be 12 minus 9 would be 3, and this will be, now this is also index is 3, so this will be 21 minus 0. So minimum of these will be 3. So 3, this will go, let's just follow this orange one. This will go here. Now minimum of these two, since they both are same, so minimum will be 3 only. So it is going to return back 3, and we are going to display 3. So that's what tracing a function, and that's what our answer is. This would be the minimum if you separate into two groups. So that it and you see this tree explode all the possibilities, and that is what happening internally. Alright, so we'll meet you in another video. Bye bye.